Snapple. I love their new white tea. It's lighter, high in antioxidants, and decaffeinated. But guys, somebody's gonna tell me, what is white tea?
White tea is a baby tea leaf, and while it still has naturally life flavor with pumpkin.
That's it?
That's it.
New all-natural Snapple white teas, the lightest tasting tea and delicious fruit flavors.
What's up, guys? We have a new week, which means we have a new wardrobe theme. You guys voted and you chose hats from my past, so I'm just going to be wearing different hats from different stages of my life. So the one for this week, it's from Gulf Shores, Alabama. I got it from Gulf Shores, Alabama, because that's where nationals for track and field was when I was a senior. That was in 2017, a senior in college. I made it for hammer, and I threw, and I definitely participated, and I placed 22nd, but it was a good time. Gulf Shores, Alabama. First time I'd ever seen the Gulf of Mexico, actually. This week we're talking about ionic bonds. It's a type of bond that an atom will make in order to form compounds with other atoms. Now, I have two magnets here, and these magnets will stick together. And the reason they'll stick together is because they have opposite poles, or they kind of have opposite charges. And atoms will do the same thing too. When they take on opposite charges, they will stick together and form bonds. Stick around, I'll get into more detail on that. So imagine with me that there is such thing as an Oreo convention, all right? It's just I don't know, it probably exists. We're at OreoCon 2020. And here's what you do at OreoCon. You go and you eat Oreos and you talk about Oreos, and that's about it. And so let's say that there's two people at OreoCon, two types of people. The first person here on the left, this guy has not eaten for days. He has been keeping himself from eating like a week in advance of this thing, because when he knows that when he gets to OreoCon, he wants to just indulge in Oreos. So this guy on the left, he's starving. He's practically starving, right? He is really hungry. He wants some Oreos. He will do anything for an Oreo. Now let's imagine a different sort of person. Let's imagine someone who's been at OreoCon for a while. This is the person on the right. And let's say that this person has been here a while. He's been eating Oreos for like a day straight, 24 hours nonstop. And this guy is so full that if he even looks at an Oreo, you'll notice here that his eyes are closed. If he even looks at an Oreo, he's going to throw up. Okay? This guy is absolutely full. He could not eat even one more Oreo, but you'll notice here that he has one Oreo left over. Now, if these two were to come across each other, if they were to run into each other at OreoCon, what do you think would happen? What do you think would make sense? What would make sense to you for what would happen? And I think the answer here is that these two are really a match made in heaven. This guy, he's eaten so many Oreos, he doesn't want his Oreo anymore. And this guy is desperate to get even one Oreo. And so I think it's obvious here that what will happen is this guy will go, whoa, man, I don't need this Oreo anymore. I'm going to give it over to you. And so we'll see here a transfer of Oreos. But why are they transferring their Oreos? Why is this guy giving away his Oreo? Well, because he's already full. He's already eaten as many Oreos as he can hold. Now, I want to come up with an analogous situation here. Let's say that we're at Valence Electron Con 2020. And so similar situation here. Over here we have fluorine. Now fluorine, you'll recall, has 9 protons. That's its atomic number. But it also is in group 17. It's a halogen. So that means it has 7 valence electrons. So it has 9 protons, 9 electrons. 7 of those 9 electrons, 7 of them are valence electrons. And so right now its charge is 0. But remember, the thing about having 7 valence electrons is that it could really use another valence electron. It is almost full. It really wants to have 8 valence electrons, but it only has 7. Do you see this, this lone electron over here? It really wants a partner. Now, alternatively, over here with lithium, look at lithium. Lithium only has 1 valence electron. It's got 3 protons, 3 electrons, but only 1 valence electron and a charge of 0. Now, this situation is really similar to the Oreo convention, and here's why. Remember last week, we talked about how the metals like lithium, potassium, magnesium, it's much easier for them to lose 1 electron than to gain 7 more. So like look at lithium here. If lithium were to just lose this 1 electron, it would be great, right? It would be great because its next lowest layer is full. Something I haven't taught you yet is that the first layer of electrons is full after only 2 electrons. It doesn't need 8, it just needs 2 to be full. But after this first layer, it needs 8. So it's easier for lithium to get rid of 1 electron. So we see here lithium really wants to get rid of 1 electron. Fluorine really wants to get 1 more electron. And so you can probably guess what's going to happen here. What would make sense is that lithium would take its electron and give it to fluorine. So then lithium would be happy because it lost its electron, and then fluorine would be happy as well because it gained its extra electron. But notice something here, that since fluorine gained an electron, it now has 9 protons and 10 electrons, which means that its charge would now be -1. And then here, lithium lost an electron, so its electron is no longer 3, it now has only 2 electrons. And so if it has 3 protons and 2 electrons, its charge is no longer 0, its charge is now +1. All right, so now we've got 2 oppositely charged atoms. The fluorine is now -1 charge, and the lithium atom is now a +1 charge. So what will happen at this point? After lithium has given away its electron, what is going to happen at this point? Well, think about it like a magnet, right? Fluorine now has 8 valence electrons, but remember, 1 of them it got from lithium. And lithium no longer has any valence electrons, really. It gave away its 1, right? So that means lithium now has a positive charge and fluorine has a negative charge. Well, what's going to happen here? Well, think about 2 magnets, right? 2 magnets, the reason why 2 magnets stick together is because they have opposite poles or they have opposite charges. And so the same thing will happen here. Since fluorine now has a negative charge and lithium has a positive charge, these 2 will now be attracted to one another. And so now we will have fluorine kind of sticking to lithium. Lithium's got a positive charge, fluorine's got a negative charge, but they're kind of attracted to each other. They're kind of sticking together, kind of like 2 magnets stick together. And this is what's called an ionic bond, right? An ionic bond is when 2 atoms kind of are attached together because they have opposite charges and they're attracted to each other. And so ionic bonds is what we are going to talk about today. So there's a number of important things you should understand about an ionic bond. So ionic bonds happen when atoms steal or transfer electrons from other atoms. So you'll notice here, right, lithium gave its electron, like the electron left, it completely left to the lithium atom and went to fluorine. So in a sense, fluorine stole lithium's electron, or lithium transferred its electron over to fluorine. And so in that same way, ionic bonds are bonds that happen when atoms steal or transfer electrons from one another. In the cold open here, you saw that Lipton tea commercial. It always reminds me of ionic bonds, because ionic bonds are formed when we take the valence electron and we pluck it. So like, for example, here, fluorine took lithium's valence electron and he plucked it and he took it away from him. So that's kind of my reason for putting that video in the beginning. Now, the atoms will stick together at this point because they are opposite charges. But something really important you need to know here, okay? And I'm going to circle this, and I put it in green. It's that important, okay? Ionic bonds only happen between metal and non-metal atoms. So you'll notice that on the last one, we had fluorine and lithium together. Well, fluorine is a non-metal, lithium is a metal, so they can do an ionic bond. But let's get fluorine out of here. Let's say it was lithium and magnesium. Could they do an ionic bond? The answer is no. No, it's not happening, because lithium and magnesium are both metals. So ionic bonds only take place between metals and non-metals. So just to summarize here, lithium gave its electron to fluorine, and when that happened, lithium took on a positive charge, and fluorine took on a negative charge. And because they are oppositely charged, they are now sticking together. And the fact that they're sticking together is what we would call an ionic bond. So this is an ionic compound, lithium fluoride, because it is being held together by an ionic bond. And lithium, in this case, is a metal, and fluorine, in this case, is a nonmetal. So these two can make an ionic bond. Now, I want to introduce another concept here, and this concept is called ionization energy. Now, the ionization energy of an atom is the amount of energy it takes to pluck an electron from an atom and make it an ion. So just think about like that tea leaf in the commercial. You can imagine a situation where it was just super easy to pull off that tea leaf. So that would be a low energy that it took to pull the tea leaf. But you can imagine a stronger plant where that tea leaf is really tough to pull off. Like it takes a lot of strength to do that. And so it would take more energy to pull off that tea leaf. So that's kind of the same idea here. The ionization energy is the amount of energy that it takes for you to rip off a valence electron from an atom. Okay? Now let me ask you something. What atoms do you think would be the easiest to take an electron from? So in other words, what atoms do you think would be the lowest ionization energy? And in order to answer that question, you'd have to think about the periodic table. Now, this is a periodic table. All I did is I took away that middle section because we're only really concerned with groups 1, 2, and then 13 through 18. Now, think about this. Out of all of these atoms, which ones most want to get rid of their electron? Because if they really want to get rid of their electron, then you would think that they would have a low ionization energy, and it would be easy for them to have an electron taken away from them. So I'll just let you think about that for a second. Which atoms here want to give away their electron the most? Opposite question. What atoms do you think would be the hardest? What atoms here do you think want an electron the most? And they're going to hold on to their electrons that they already have the strongest. Well, let's answer this question here. Okay? So what atoms do you think would be the easiest to take away an electron from? Well, remember, we talked about in the past how these metals right here, they tend to lose electrons. they want to lose their electrons. You don't have to take away their electron. They'll just give it away to you. So that means that these metals right here have a low ionization energy, right? They have a low ionization energy because it's easy for them to have their electrons taken away. But on the other hand, what atoms do you think would be the hardest to take an electron away from? Well, it's got to be group 17, right? Because group 17, they have 7 valence electrons. They only need 1 more to get to 8. And so they really, really want another electron. And if they really want another electron, they're not going to let go of the electrons that they already have. So in this case, group 17 would have high ionization energy. Okay, so the rule of thumb here is that the closer an atom is to fluorine, okay, you guys can see these arrows going here for ionization energy. The atoms with the highest ionization energy are up here by fluorine. So the closer an atom is to fluorine, the higher ionization energy it has. Okay, that is the big rule here. I explained these other things here so you understand why that's the rule, but that's the rule. So let's do a couple of examples that you might see in your assignments for this week. So how about this one? Which of these combination of atoms will form an ionic bond? Now remember, ionic bonds are formed between metals and nonmetals. That's it. So lithium and sodium, let's look at that. Will they form an ionic bond? Well, lithium is right here, and sodium is right beneath it. Now notice, these are both metals. Lithium's a metal, sodium's a metal. So that means it will not form an ionic bond because they're both metals. What about iodine and magnesium? Well, iodine is over here. Notice that it's blue, and so it's a non-metal. And then magnesium is in the gray over here. It is a metal. So that means B is our answer, right? Because iodine is a non-metal, magnesium is a metal, and so they will form an ionic bond. What about calcium and silver? Well, here's calcium right here. And then silver, Ag, is, where are you, silver? There it is, right there. So silver is a metal, calcium is a metal. They're not going to form an ionic bond. Only iodine and magnesium will. So that's one sort of problem you might do. Example 2. Which of these atoms will be the easiest to take away an electron from? Which means it has low ionization energy. Okay? Remember, the rule of thumb was that the closer an atom was to fluorine, the higher ionization energy it had. So the higher ionization energy an atom has, the stronger it holds on to its electrons. So the question is, though, which one would it be easiest to take away an electron from? So we have to ask, which one of these is the farthest away from fluorine? Silicon, nickel, chlorine, or beryllium? And you'll notice here that beryllium is very far away from fluorine. It's even farther away than nickel, wherever that one went. Here it is, right? So since beryllium is the farthest away from fluorine, it will have the lowest ionization energy, right? Beryllium is a metal. It's going to lose its 2 electrons. We already talked about this last week. And so since it will lose its 2 electrons, it's just going to give away its electrons. It's easy to take beryllium's electrons, okay? So beryllium in this case will have the lowest ionization energy. That's it for this week. Show up to Zoom.